Good morning, everyone. My name is Karthik and my partner is Saram Reddy. Today, we are presenting our project on context-aware sarcasm and irony detection in social media text, a deep learning project we built using transformer models. So let me start with the problem. When someone posts online, "Oh great, another Monday, absolutely love sitting in a traffic for 3 hours," the words are completely positive, but the real meaning is the exact opposite. This is sarcasm, and the AI systems fail to detect it every single time. This causes sentiment analysis tools to flip their scores, content modernization moderation to miss harmful comments, and opinion mining tools to give completely wrong insights to businesses. The root cause is simple. Every existing approach looks one sentence in isolation with no idea. So what came before in conversation, that is the gap we are addressing. So this slide shows how our input is structured, and instead of feeding just the reply to the model, we feed both the parent post and the reply together in one sequence, separated by special tokens. This single design change allows the transformer to directly compare words across both conversational tones and detect the mismatch that defines sarcasm. So for our dataset, we used SARC 2.0, a large Reddit corpus with 1.3 million sarcasm label comments. What makes this dataset unique is that the user labeled their own posts with A or S marker, so labels reflect genuine author content. So each example comes with a target commented and the parent post that gives context. We clean the text by removing the tags, and which is critical to prevent label leakage, and also replace URLs and usernames with special tokens. This chart show our dataset is perfectly balanced, 50% sarcastic and 50% not sarcastic. So we sampled 50,000 examples from the full corpus and split them 80% to training and 10% for validation and 10% for testing. Our model is built on Roberta base, a large transformer pre-trained on hundreds of billions of words. So the key design decision is on our input format. We concatenate the parent post and the target reply into one sentence like this: the CLS token, parent post, separated token, target reply, and then separated token. This early fusion approaches allows every one of the 12 attention heads across all 12 transformer layers to directly compare any word in the context with any word in the reply in a single forward pass. On top of Robata encoder, we added a two-layer classification head that takes the CLS token output, passes it through a linear layer, ReLU activation, dropout, and produces the final prediction, sarcastic or not sarcastic. We trained using Adam W optimizer with a learning rate of 2e-5 for 3 epochs. And this diagram visualizes the full model pipeline from raw text input through the tokenizer into the Roberta encoder through the classification head and finally to the output prediction. You can see how the context and reply flow together through the entire network. So these are the training curves that shows that our model learned consistently across all three epochs. Training a loss decreased steadily from 0.59 down to 0.40, and validation F1 improved every epoch, as we can see here. This is our main result. We compared our model against four baselines: by LSTM, Text, CNN, BERT without context, and Roberta without context. So our context-aware Roberta achieves a macro F1 score of 0.7434, the highest of all the five models. We outperform the BiLSTM baseline by 22.9 F1 points and the Text CNN by 6.85 points. And most importantly, we outperformed the Roberta without context by 4.0 F1 points, which directly proves that adding conversational text is key improvement, not just the model architecture. To directly prove our hypothesis, we ran an ablation study. We trained four versions of the model: one with zero context turns, one with one turn, one with two turns, and one with three turns, keeping everything else identical. The results are clear. Zero context gives f1s of 0.70, one turn jumps to 0.72, two turn reaches 0.74 as you can see here. Three turns gives us the best results, which is 0.74. Every additional turn of context helps the gains slow down after three turns because very long histories start introducing noise, but the trend is consistent. Context always helps. This is one of the most interesting findings. We visualize the attention weights of our model on a sarcastic example and non-sarcastic one. So in the sarcastic sentence, the left one, you can see the model assigns very strong attention between the word pairs like love and Monday. In the non-sarcastic sentence on the right, the attention is spread out uniformly. This tells us the model genuinely learned to detect semantic mismatch. So the error analysis shows that 73.8% of our predictions are correct, combining true positives and true negatives. The remaining errors are split between false positives, where the model mistakes genuine enthusiasm for sarcasm, and false negatives, where subtle understanding with no obvious lexical signals gets missed. So the confidence histogram shows that correct predictions cluster at high confidence above 0.9 while errors are spread across lower confidence values. We did not just stop at the training our model, so we actually deployed it at a live web application using Streamlit. As you can see on the screen, the app has two input fields, one with the parent post and the context, and one for the reply you want to classify. The user types both and click detect sarcasm, and the model instantly gives the prediction with the confidence score. So yeah, the app also shows the exact confidence breakdown. So here it's 36.2% sarcastic for this example and not sarcastic 63.8%. So this model is hosted on Hugging Face and the app is live on Streamlit Cloud, meaning anyone with the link can try it out. So to summarize, we have three key takeaways. So first, context is everything. Adding just one conversational turn improved F1 by over 2 points. The reply alone is never enough. Second, transformers dramatically outperformed classical deep learning models. Robota beat by LSTM by nearly 23 F1 points. Pre-trained self-attention is far superior for understanding figurative language. Third, input design matters just as much as model choice. We proved that taking the exact same Robota model and simply feeding the context alongside the reply improved performance by 4 full points, F1 points. So to conclude, our context-aware Robota achieves a final macro F1 of 0.4234, outperforming all four uh, baselines and directly proving that conversational context is essential missing ingredient in sarcasm detection. Thank you.